Hello students, welcome back. Welcome back to the world of RoboMate. So students, let us start with the next module of the chapter circular motion. In this module, yes students, we are going to discuss the concept of centrifugal force. Already we have seen centripetal. In this module, we are going to see what is centrifugal. Okay? Can I start with the module? Alright. Now students, first I am going to define what is a centrifugal force. Alright, for that I am considering a particle. This particle is performing a uniform circular motion. Now, point O is the center of the circular path traced by the particle. Now students, we all know in UCM, this particle will experience an acceleration called as radial acceleration, AC, or centripetal acceleration, and this acceleration will be acting towards the center. We saw this. And we also saw centripetal force. This acceleration is produced by a force called as centripetal force, and that centripetal force will also be acting towards the center, and that centripetal force is a real force. We have seen this in the last module. Now students, let us say you are observing this, alright, and you are in an inertial frame. Now, if you take the particle as the frame of reference, particle as the frame of reference means you go into the particle and then you observe. So if you take the particle as the frame of reference, what will happen? The particle is accelerating, there is an acceleration. So acceleration means then that frame of reference will become non-inertial frame of reference. So then what will happen? Non-inertial frame of reference, you will have pseudo force. So that is called as your centrifugal force. So if you take the particle as the frame of reference, that particular frame of reference is accelerated, so you will experience a pseudo force called as centrifugal force. Alright, and that force will be acting outward, away from the center. So you have to get into the particle to experience this. From here I see, oh nice, particle is performing circular motion. But if I get into that particle, I am in an accelerated frame. So I will experience a pseudo force, and that force is called as centrifugal force. So definition is, if the reference frame of the particle performing circular motion, centrifugal force is defined as pseudo force, alright, directed outward on the particle and is equal in magnitude to the particle's mass times the centripetal acceleration of the reference frame as measured from inertial frame of reference. Is that clear? So centrifugal force arises if you take the particle as the frame of reference. So then it will become an accelerated frame, so you will experience a pseudo force. What is the formula for centrifugal force? Is already given there. Mass into your centripetal acceleration. So FCF is m omega square r. Alright, and we know omega is v by r, so FCF is mv square by r. So we have two formulas. So remember this, to experience centrifugal force, you have to be in a non-inertial frame. Alright, so you have to get into that particle, so then your frame will become non-inertial accelerated, and then you can experience centrifugal force. Is that clear? Formulas, you see it is same as your centripetal, but centripetal is towards center, this one is away from the center. Okay, now students, let us see some examples. You see here what's happening. See there. This is a merry-go-round. The people on the merry-go-round, they are experiencing an outward push. You see there? They are holding on to the rails. But the person standing on the ground, you see there, is he experiencing any push? No. But the person on the merry-go-round, he is experiencing an outward push. Why? Because those people on the merry-go-round, they are in non-inertial frame. Non-inertial frame. Why? Because they are moving in a circle, so they will have radial acceleration towards the center. Alright, so they are in a non-inertial frame, and non-inertial frame means there will be a pseudo force, and that pseudo force is your centrifugal force. It is acting outward, away from the center, so they are experiencing an outward push. See there. One more example. See here. Look at this. Look at that boy. He is stretching. So much centrifugal force is acting on him. Look at him. He is on the merry-go-round. Merry-go-round is rotating. He is on the merry-go-round. He is performing a circular motion, and he will have a radial acceleration towards the center. So what will happen? There will be a centrifugal force. Why? Because he is in a non-inertial frame. So he is stretching. See there. The centrifugal force is pushing him out. This is a slow motion animation. Alright. In real time it will be different. And you see the boy on the ground. He is experiencing any push? No. But once he knocks him off, he falls down. But the people on the merry-go-round, you see them. They are all holding. They are scared. They will be pulled out. Alright. Yes. Centrifugal force will push them out. Is that clear? So this is your centrifugal force. Alright. So keep this in your mind. A person in a merry-go-round experiences a radially outward force called as centrifugal force. Why? Because he is in a non-inertial frame. accelerated frame. Alright, one more example that we can give is a coin kept on a rotating turntable. Alright, and that turntable is rotating. When it rotates at a very high speed, the coin will fly off. That is also because of the centrifugal force. Is this clear to you? So if you're on an accelerated frame, then you get this centrifugal force. That is, if you get into the particle, then you will have the centrifugal force. Any doubts in this, students? No. So students, here we have defined centrifugal force and we have seen the formula. Alright, so I'll catch you up in the next module. Until then, students, keep working. You can do it. Rise and shine.